Okay, so homework. We were to write the thing to get a element at a specific index and also remove at an index. And what we were really exploring last time was kind of implementation of these. We were starting to talk about data structures and how some of our existing data structures that we know about are actually implemented. So we know about arrays and array lists, and arrays we can consider to be really fast because the buckets of an array are mathematically computable, right? We can, just say to go to bucket 5, we can calculate the base address plus 5 times the size of what we're storing and get right to that memory location. It's fast. But to make an array of a new size is destructive, and that's expensive from a memory efficiency perspective. Well, we have this thing called an array list, which we effectively bought at Home Depot, right? We didn't necessarily know how it's built, so we're going to make a worst case assumption because it benefits us towards moving towards linked lists. But these guys are not limited by the original construction for whatever reason. Okay, we don't know why. It might as well be an actual destructive array under the hood, where what we don't know doesn't hurt us. And we can say they're relatively slow if that's not the case. So if these guys are built like linked lists, which is what we're kind of segueing into, then we can say, well, they're not limited by their original construction because their original construction might be smart. Okay, they maybe did not implement them as destructive arrays, even though I think we're going at the destructive array version of this for our assignments we've been working on, right? Therefore, from a performance perspective, they're going to be relatively slow, but they're going to be memory efficient because we don't need all that contiguous memory in a row. Okay, so that might be our hope. That's kind of the alternative here. But we're implementing an array list that is the knockoff that we might buy from Home Depot that's actually implemented in terms of arrays. But from our perspective, hey, we could just keep adding stuff to it, no harm, no foul, even though under the hood, great destruction is occurring, right? Okay, so let's go back in here. So we were supposed to write get at index, and I think I said you can assume that the index is a legal bucket. We don't have to do the error checking for this. If you did error checking, it's only a couple of if statements. We'll, whatever. Actually, just so we can be a little bit more complete in here, let's talk about it. So let's do, if we do get at index, what would illegal indexes be? It would be something that's what, less than. Okay. Well, that would be legal. So illegal. Yeah, illegal. So what are we're going to have two ends of the thing. What are our illegal positions? Less than 0 and greater than. Greater than data or greater than or equal to the length. Yeah, whatever. However you want to write it. So we can say something like if index is less than 0 or index is greater than, you can say greater than or equal to if you want, this dot data dot length. That means this guy is in a legal position. And what do we do with illegal positions? How do we handle this? So this becomes kind of an interesting, I guess, programming approach. So right here, I have advertised that I have a method called getAtIndex, takes an integer as a parameter, and this guy returns a string. That means he must always, 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 always return a string. But now, I've determined that, hey, the position you've asked me for is not a legal position. What are my options? As I have it written right now, I have to return a string.
String that says check your input if you really wanted to.
Okay, so I could to go kind of lazy route and do check your input and hope that the moons didn't align, and I actually asked for bucket 7, and bucket 7 happened to equal the string check your input, right? So now we have kind of like check your input, the actual value, or is it my error value?
And I guess if they're trying to actually put that string somewhere in like another method, that screws things up.
Yeah. Okay. So, but certainly an approach, but an approach with a downside. Okay. And that's good. That's kind of what I'm working towards. I don't remember. Did we talk about exceptions last semester? We wrote exceptions? Okay. Well, that's good. So that probably should be our next answer. So, what's an exception? Did we actually write exceptions, or did we just deal with exceptions? Did we like just write try-catches?
I think we did Trycatch.
We never wrote our own exception. If we did, you don't remember because you did so much programming over break. All right, so tell me what you know about exceptions. What are these guys? And what's their purpose? Okay, so one thing that we don't want is we don't want programs to, I guess for lack of a better phrase, crash in an unelegant way. Or inelegant way, which is what? Inelegant, okay. So we'd like them to slowly flutter to the ground as they're crashing. So, you know, if we just let something bad happen, all right, so for example, let's, here, I'm just gonna, for the sake of this guy compiling, I'm gonna just return an empty string here. And we'll return LOL here, and then everybody will be happy again. We need to return something here, so we'll just throw the empty string in there for right now. And I think we compile again. All right, so let's say that I challenged you to make this program crash in a inelegant way. What line of code could we write here that would actually allow the program to run, which means it would compile, but it would crash at runtime? That would be a runtime error based on what you know right now. And I'm sure many of you have written plenty of crashes, so you should have a whole bunch of options just waiting. I've never introduced an error into any of my code. Never once, actually. It's a curse. What always happens is the compiler messes up, or there's a keyboard malfunction more times than not. Any ideas? What if I do something like integer.parseInt hello? Is that going to cause a problem? Yeah, try to, what are you expecting out of that? I want to squeeze the integer out of the string hello. At the very least, you should have real low expectations, right? All right, so this guy is going to give us a null number format exception, blah, blah, blah. But exceptions kind of come in a couple of flavors. We have exceptions that we are forced to deal with, right? Exceptions that we're forced to deal with. But we also have exceptions that we can choose to do a try and a catch and deal with it gracefully. So something I could do here is I could come into my A list, and we're going to say that we still have to forget an index, even though it's in a legal position. We can still say something like, check your input or whatever you suggested. Okay, but maybe before that, we can say something like exception E is equal to a new exception, and we can just come up with a an error message. Maybe we call this guy check your input. All right, so we have an exception kind of ready to go, and then we can say throw E. And let's just comment this guy out for a second. All right, so hover over this guy. So this guy says unhandled exception type declaration. So we can either add a throws declaration, which we're going to end up doing up here. We're going to say that we're going to advertise that this method throws an exception. Did we do those last semester? Or is that's not ringing a bell?
We actually did them with Blockbutter and 370.
Okay, so you've seen them. You've seen them. Okay. Well, actually, a lot of you are in 370 now. So you did it like last week. You saw this. Okay, I got you.
We didn't necessarily talk about the theory of it a lot.
No, I got you. So you haven't covered it with me in the under the hood stuff. Okay. Or we could surround this thing in a try-catch and kind of deal with either one of these things. So if we did the try-catch approach, then that would allow us to either throw this exception, or it would allow us to return a string where, you know, the throw exception would make us crash in a inelegant way like we just saw parseInt do. You know, we would basically crash with red stuff, right? all over the giving us our error that says check your input. All right, so what we would probably want to do in real practice, we would probably want to advertise that this guy throws. In real life, you would probably write a sub and you would inherit a class from exception that is like a special kind of exception, you know, a array index out of bounds exception or something like that. But we'll just use generic exceptions for right now, just with our error message telling us the difference. I'll talk about why you might want to have different kinds of exceptions in a few minutes. But so what we can do is we can say we're going to throw an exception. This guy potentially throws an exception. So what we can do in here is we can say, and I don't even need to create the variable. I can just say throw a new exception, check your input. Or I can return this dot data at bucket index. So those are my options there. So I pass my index through a filter and I say, is the index you gave me a legitimate index, or is it going to be problematic? Because we know that if I try to say return this dot data at bucket -4, bad things are going to happen. We're going to get an array index out of bounds exception that the array class implements for us. But we're going to go ahead and try to gracefully deal with this, and we're going to wrap this, and we're going to say we're going to throw our own exception here. But not only are we going to throw our own exception, we've also advertised that this method throws an exception. What does that mean? So you said you talked about it a couple days ago. What does it mean when I say that a method throws an exception? How does that impact our lives as a programmer? Did we write add last time, or we still have to write add? We wrote add. Okay, so I could add crap to this. All right, good. All right, so I'm going to go ahead and say lst.add. We'll just do some alphabet stuff. And what does get data do for us? Does that just print it all to the screen? Oh, it's actually our array that gets returned, right? This is our getter, and then it just happens to, this is going to print memory address, right? That's what we're looking at. Okay. I think that'll still be a memory address. It will still be a memory address because that's what's ultimately getting called. So let's just write a quick little display method here for this guy so we can actually look at the contents of our list. Actually, have we done for each loops in here before? We might as well introduce those now too. So right now we have a collection of strings. So I could write that standard for loop that says, you know, take I on a voyage from bucket 0 up to but not including data.length. And then each time through I can say something like system.out.print. We'll do println since they're strings. And then we'll say this dot data at bucket I. Something like that. So that'll go through and it'll display the contents of our list, right? And I'll come back, I'll show you the for each loop in a second. So let's go ahead and test that. So we'll say lst.display, and let's get rid of our error crashy thing here. All right, and we'll go ahead and run this. So there's our proof of that guy's actually a memory address, and there's our display of the contents of our list after we called add a couple times. So we have A and B. All right. Now, Sometimes, as is the case in our current implementation, we're not manipulating this array. We don't actually need the value of I. We're only using the value of I here to index a specific place in data. So if I want to write the equivalent loop as a for each loop, I can say for string s in this dot data. That's effectively what that's saying. So I'm saying it out loud the way it implies. This is the syntax for it in Java. Other languages deal with it slightly different. So for instance, in Swift, it would be for s in, well, in Swift it would be self.data, but whatever. So it would look something like that in Swift, but pretty similar type setup, right? All right, so for s in this dot data, then we can just, we'll steal this line right here, but instead of this dot data at bucket I, we'll just print out s. So it goes ahead and it grabs each of our strings from that guy. So this will have the same output as the other guy would have had, with the exception that we don't have access to the contents of I here. So if we needed to know at what bucket a particular string was living at, if we were searching through there for a string, we wouldn't get that information because we don't have the I. We can cheat it and say something like, we can say int pos is equal to 0, and then each time through here we can say pos plus plus. So we would have the position. We're just adding that ability into it if we wanted to. But generally you'll use your for each loops when you just need to spin through some data and get some stuff when you don't actually need that index value. All right, so kind of a convenience type thing for us. So we see the output is the same. So any questions on for each loops? How did I introduce those last semester? Sometimes I do, it's all situational as to whether or not we bump into needing that. So I'm trying to introduce as many reasonable tools to your toolbox as you can. That way I can ask you completely unreasonable programming assignments. The more tools you have, the harder assignments you can do, right? Seems like a reasonable. Seems everybody's very excited about that. Yeah, there always adds a little excitement when I don't actually solve your homework assignments until we come to class and I do the solution. Because then there's all the sorts of like surprises that might happen when I actually think about it but didn't think about it. Highly entertaining for me. Probably ruin some of your weekends, but not really my problem. So, as we talked about last semester, human misery is one of my hobbies. All right, so I'll leave that in there for now just so you can kind of see the difference. So we know how to display this guy. And now let's go ahead and let's look at the side effect of this. So I'm going to go ahead and try to get something at an index. So my legal indexes right now, since I've added a couple of strings to this, I could pass it a 0 or I could pass it a 1, right? Both of those guys should work. So I'm going to go ahead and we're going to say system.out.println, and we'll say lst.getAtIndex, and the index I'm going to pass it is a 0. All right. So we just said out loud that a 0 or a 1 is a legal index, right? Why is it screaming at me? Why is it not happy? This kind of goes back to something similar to what we dealt with near the end of last semester when we were talking about abstract classes. The second we threw the throws clause, the second we put that throws clause on the end of that method, we added an obligation. And we said, because I'm advertising that this method might throw an exception, I am now obligating the programmer who might call my method to deal with it. Okay? It's now their problem. Now, we have two options here. We could be a good, conscientious programmer, or we could be a lazy programmer. So for those of you who've dealt with throws before, what are my couple options? What would a good, conscientious programmer do here? Throw a trycatcher in. Deal with the exception. So we would say, we're going to try to do this crap. So here we got this dude. We're going to try to do that. And in the event that it zigs when it's supposed to zag, we'll say catch, a slightly lazy conscientious programmer, which in this case is completely reasonable because we actually made our exception a generic exception rather than an exception of a specific flavor. We can go ahead and we'll just say catch exception E. And then we can say something like, was it Bazinga? Is that how you spell it? So that's it, right? It's on the t-shirts. It's Sheldon, right? Yeah, see, nailed it. So notice Eclipse isn't screaming at us anymore. We have been good conscientious programmers. We recognize the fact that this particular method here had a throw clause on it, so getAtIndex, which we wrote in here, which we advertise as potentially throwing an exception, now means that when we come in here, we have to try to do that and then potentially catch the exception. Now you can have multiple catches associated with a single try. So we might have 50 lines of code inside of this try, and inside that 50 lines of code, there might be 3 or 4 or 5 or 10 different types of exceptions that might occur. We might have an array index out of bounds exception, we might have a number format exception, all sorts of different exceptions, okay? Because we might want to handle different exceptions differently, right? We might want to handle an array index out of bounds exceptions one way, and we might want to handle a number format exception a different way. Now, all of those different kinds of built-in exceptions all have a common parent, the generic class exception, okay? So when we say catch exception E, we're really saying if anything goes wrong in here, catch it here. So we're not really being very discerning in terms of what errors we care about. We're just trying to get Eclipse to not scream at us. That's really what it comes down to, okay? But because we put that throws clause in there, we've now added an obligation to ourselves. All right, so that's one option. Now, what would, only a few of you might know the answer to this. What would a lazy programmer do here? Go ahead. Replace the throws clause with what?
Something easier, like previously how you returned something and stuff.
Oh, okay. Yeah, so that would be super lazy. That's the super lazy programmer. So now we're dealing with the lazy but somewhat conscientious programmer. The lazy programmer who went through the process of understanding that, you know what, if I just return some other string here, I'm potentially running into problems where that other string might actually be equivalent to something that's in my data set. Okay? And this is a common problem throughout actually the history of computing. This is really what we've seen through from our databases evolve. In the early days of flat file databases, when they just stored stuff next to each other, they had to pick a delimiter for splitting lines up. Well, how do you know that that delimiter wasn't in your line? So all you can do is come up with like crazy, if you want to write one that's like very, very unlikely, you can say that, okay, well I have, maybe I have strings that are delimited by something like, so let's say we have, our individual strings are A, B, C, D, E. Well, we can't say space is a delimiter because we could have something like DO space G, and maybe this guy is one of our elements, and that guy has a space in it. Okay, so spaces aren't going to work. So we need to replace these spaces with some delimiter, something that splits those guys up. Well, common things might be things like commas. Well, is a comma something that might end up in your data? Sure. So then you got to start inventing sequences of characters. So maybe we say, okay, these things are going to be separated by maybe the little smiley tongue face in there. 3. Okay, so that's our delimiter for each of our strings. Okay, and we're just going to cross our fingers and just hope that some crazy lunatic doesn't actually have one of their their datums equal to that. Okay, can any of you with 100% certainty guarantee that nobody will ever have a datum that matches that? We could probably give you a pretty high certainty, right? Seems unlikely in anything reasonable, but not impossible. So that would be, we're kind of taking a pretty big risk there. All right, so given that, what would a slightly conscientious programmer who wouldn't just do the cheap move, what could they do here to still be lazy? Go ahead.
If you're thinking runtime exception instead of a generic exception or some subclass of it.
Okay, so rather than make this guy a normal exception, if we make him a different breed, then he comes with a little bit different rule associated with it. Okay, fair enough. Fair enough. Let's assume that we're going to leave it as a normal throws exception. But you're right. So, for example, what we saw earlier with the number format exception, %, is a runtime exception. And we know that because when we called integer.parseInt, it didn't force us to surround that guy with a trycatch. Make sense? All right, so we could say this guy throws a, I think it's just like that. So everything else looks similar, but when we come back out here, notice it's now cool with it. Make sense? So that's probably what we'll want to do in our program from the perspective of something bad could happen, but we really don't care. That's probably what we'd want to do. But just so we can see the other side of the coin here, if we decide we're going to deal with everything as just generic, normal, plain Jane exceptions, but we still, don't want people to get the wrong idea. We still want to make sure people realize that we are lazy. What option do we have here to not use a try-catch, but still have Eclipse not complain about this by only making a change to this file? We're not allowed to go back to a list right now. Go ahead.
You can add a throws exception to the main.
Pass the buck. Pass the buck. Hey, all we can say is, all we have to do is do this. We can say throws exception up there. And what this says is, hey, we're advertising that main throws an exception. So that means anything bad that happens in here, rather than us dealing with it, pass the buck. Okay? Whoever called me gets to deal with that. I'm just going to pass that exception on to you. Who happens to call main? Remember, we go all the way back. We talked about all programs begin and end with main. So based on what we know about Java, who's in charge of calling main to begin with? Probably the Java virtual machine. He's the guy that gets when we hit the play button, we saw last semester kind of what happens under the hood, right? There's a compile, there's javax space, the name of the file, then it creates the .class file, then it's java space, the name of the class, and that's when it actually is getting called. Well, it will be that dude who has to then deal with that exception. And he will treat it as a runtime exception and just spit it to the screen. Okay, so what he ends up doing, well, he'll treat it as if it was a runtime exception, but he has to deal with it as if it's a normal exception. So he would do the equivalent of this. If we dealt with this exception the same way that the Java virtual machine would, it would look something like this. A lot of times they do print stack trace, that guy. Let's take a string in. I think that'll do it. Still not happy? Let's just go back to my beginning. Oh, that takes a print stream. Print writer. All right. Let's just leave it at E. That'll look like an error. Good enough. We can go down the lines and look at different ways of doing that. But so we're going to catch the exception, and all we're going to do is print it out. Pass the buck. Make sense? So that's effectively what the Java virtual machine will end up doing if we just pass the buck. So that's certainly the lazy way of doing it because try catches are inconvenient, to say the least. So now, which is the way what should we do here and why? Assuming we're not allowed to change anything in A-list right now. So we're leaving this guy as an exception. What would be a reasonable thing for us to do in here? Do we play the lazy programmer and pass the buck? Or do we do a try catch? And why? Somebody other than her. Just asking you to use logic. You could argue either way. Either way could potentially be a correct answer if the why is the correct why. Go ahead.
Trycatch, because if you do throw the exception and you wind up with an error somewhere else, it's going to take a lot longer to find what went wrong.
Okay, that's not an unreasonable thing. In this case, we know that there's only one other place it's going, right? We're at the top. But you're absolutely right. If we were in a program where we had a class, call a class, call a class, call a class, and we're 10 levels down, and when we pass the buck, we're just passing it up to the dude right before us. And then we don't. Then if we're the only programmer, we're the one who has to handle that anyways. We just handle it one level up. So we could just keep passing a buck, and then it becomes a nightmare, like you're saying, where if you just pass the buck from 10 levels down and finally let this guy deal with it, you don't necessarily know where that error started. That's where the whole stack trace comes in, where you have to look at, at what point in the program did this guy actually croak? All right, so if that was the case, if we were multiple levels down, I think your argument would be very, very reasonable. In this case, we're only one level down. We know where the error came from. So what other rationale? But that's not a bad rationale. Just in this particular scenario, maybe not as convincing as it could be. Well, here, we'll ask it a little different. In your opinion, when would it be okay in this scenario right here, where we're already at the top, right? We're only one level from the top. When would it be okay to just go ahead and pass the buck? I've advertised it as only if you're a lazy programmer. But if I'm going to say throws exception there, what could you say that would make me believe that that's actually that's the smart thing to do? Because programming, while syntax is an exact science, right? We have to be very specific about it. As a programmer, we also make decisions all the time. And sometimes these decisions are no-brainers. Like when we talked about the evolution of C++ to Java, one of the things that Java did is it took a lot of the decision-making away from the programmer, right? I advertised that C++ empowered the programmer to make dumb decisions. You can hand somebody the house instead of the address to the house, okay? And we decided in real life that would never make sense, okay? But now we can, as a more advanced programmer now, we can say something along the lines of, well, never is kind of a strong term, okay? Maybe we say it rarely would make sense. Okay, so what could you argue here that would be a reasonable, other than just, hey, I'm lazy, so, show them who I am the first time. What would be a reasonable reason to just go ahead and throw the exception? Go ahead.
I guess it's not a very complex program and we'd only be doing it once. So, it's not necessarily a lot to put to the JVM. If I was going to throw a lot of exceptions in, I think it would be more questionable.
Okay. So you're taking more of the kind of the playground bully approach where, what's one punch to the gut, right? Doesn't kill them, makes them stronger, that type of thing. You should definitely go to Bible study today. I'm just saying. Are you going?
Maybe.
Free lunch.
Tempting.
Everybody.
Everybody eat lunch with on Tuesdays.
You can always sit at our table. In the past, we always just grow to bigger tables as more people show up. But we've been getting only 2 or 3 people have been showing up now. We have a very international crowd, right, Van? Yeah, I mean, there's very little English going on at the table. It's disturbing, really.
So I need to balance it out.
You need to balance it out. Or do you speak Spanish or anything?
Only a little.
Yeah, like enough to order a Taco Bell type thing.
Yeah.
All right, so I think your answer is pretty weak. Yeah, I don't like that. That's a crap answer. Yeah, I don't like that one. I mean, I get it, but I mean, the virtual machine's a computer program. Do we really care? I mean, I'm almost taking the other extension. Who cares if we're the high school, the playground bully, we punch him in the stomach 50 times? That's the virtual machine. That's what he's there for. He's the punching bag. When would it be okay for us to do the throws exception here? Or if you want to look at it the other way, when would it be preferable for us to do the try-catch? When should we do a try-catch? What's the purpose of a try-catch? If you had to kind of give me a rule of thumb for a try-catch, what it is, go ahead.
Like solving the problem on the fly, kind of. So like.
What problem are we solving?
The problem of, I don't know, you're entering the wrong address or something.
Okay, so we're handling an error.
Yeah.
Okay, we're choosing to deal with this error. Okay, the person gave us a bad input. We're going to deal with it. We're going to choose to say, hey, you gave us a bad input. Why don't you try again? Because we can't work with what you gave me. So if we're gonna choose to actually do something as a result of the error, we should use a try-catch. We should control it, right? If we're gonna choose to do something about it, we're actually going to write the logic to do it. Okay, this is our opportunity with the try-catch. Now, if on the other side we're just writing the try-catch for the purpose of writing the try-catch to make the little red line go away, with the expectation that we're not going to do anything, we're just going to effectively pass the buck by saying system dot if we want to say, if we want it to be in red, we would say system.err, system.error. It puts it in red. There's three common streams in all operating systems that are always there. We have system in, which is the keyboard. Then we have system out, and we have system error. And system out and system error are actually a shared stream that in Unix, you have the ability to split the two of them. You actually can do it in the new emulated DOS, but in old DOS, you had to go through a file in order to pull it off. So it's kind of weird. But in Unix, if I have something that has an error, I can redirect just the error messages because it's technically 2 separate streams. So if you wanted to support that knowledge, if you do system.err, you're giving whoever else is going to handle your errors down the line, maybe some logger or something like that, if they're going to put it in a log file, the opportunity to separate normal program output from the error program output. Those would be technically on 2 different streams, even though we would, by default, see them both on the screen. And it just happens to be that it puts the system.error in red for us on here. It wouldn't be in red if you just ran it at the terminal. This is an Eclipse thing. All right, so if we intend to deal with the error, deal with it. Do the try-catch and deal with it. If you don't intend to deal with the error, now the decision comes to the next step. This maybe comes back to what you were talking about at the beginning, where how many levels down are we? If we're right at the top and the only person this is going to affect is just the virtual machine, who cares? Let's pass the buck, throw it, because we're not going to deal with it anyways. We might as well save ourselves writing 3 lines of code by letting him just spit it out to the screen. No big deal. But now if we're 10 levels down in our program, by passing the buck, we're actually passing it to ourselves, right? At some point, we have to deal with it. So at that point, it's not really even more convenient. If you just are completely stuck with, I want to pass this buck, you're going to have to pass the buck 10 times. This guy passes to this class. Then we write throws exception here, right? Throws exception here, right? Throws exception here until we get all the way up to main. And we finally tell that guy to throw the exception. That's pretty inconvenient as well, isn't it? So in that case, and I would say it would almost be a rule of thumb. If you are more than 1 or 2 levels down in your program, you should probably you should probably handle the error yourself, even if you're just going to spit it out to the screen. Because it's going to be more inconvenient for you to pass it between multiple classes than just deal with it locally. And this actually maybe goes to a deeper rule of thumb. And we talked about singletons last semester, right? Okay, so when we talk about design patterns, remind me. Just throw this back up here because we're going to reference this pretty often this semester. Remind me, what's a design pattern?
Good solution for like a common problem.
Yeah, so we kind of wrote it as a proposed good solution to a, quote, common problem. So that means those guys can come in all sorts of flavors, right? What's a good solution? What's a common problem? But a couple of these guys do start rising to the surface. And one of them we talked about, we'll review it again when we get back into the Android stuff, was MVC, right? Android's approach to, not Android's approach, the approach of separating your views from your data, from your actual implementations, keeping those guys in separate places so that no one place gets too out of order. But the one we're talking about here is the singleton design pattern. Anybody remember what that one was? It kind of falls into that same category as almost like that lazy programmer passing the buck type thing, but sometimes it's okay. So what was singleton? Go ahead.
So essentially having like a separate class to throw variables where you're going to have to access that variable between more than one place.
It's a good idea to store things that need to be shared between several classes in one place. So rather than having to kind of chain pass information from this guy to this guy, and then this guy to this guy, and this guy to this guy, we can just throw it up into a singleton, or kind of a global class, and make it available to everybody. Now, this becomes a little bit dangerous. So kind of, with great power comes great responsibility. That's a Superman thing, right? Yeah. Spider-Man thing? Really? Seems like Spider-Man's powers aren't that great. Yeah, what would happen? Spider-Man versus Superman. Really anybody versus Superman. It's just like the Batman Superman movie. They what? Just have to get kryptonite? Whoever? It's dumb. Superman's too nice. He could just end it in one punch, right? It's just too kind. Now we're back to the high school bully thing, the playground bully, whatever. Full circle. All right, so singleton. If we have 3 classes that need to have access to one variable, we can certainly kind of keep things self-contained and say, well, when this class talks to this class, we're just going to go ahead and pass it through. When we dealt with this in Android, we had this thing called extras, right? That we can kind of pack stuff up and send it with the intent and everybody's happy, blah, blah, blah. Or we can take, the lazy route or the easy route, but sometimes it might be the right route, and just kind of toss it up into this class, so it's just kind of sitting up there, so that when this guy needs it, he can just grab it. He doesn't have to unpack it from the intent or anything like that. It's just there. Now, that's enticing because it's very easy. It's very convenient. Okay? To throw something into the singleton takes one line, right? It's just there. What's the problem with using the singleton? We could get singleton happy, right? And start using the singleton for everything. And all of a sudden you got this gigantic singleton that's unwieldy. Okay, there's 4 zillion things in the singleton. I don't know if I showed this to you last semester. Let me give you an example of this. I think, is this the one that has the crazy one? So that's their singleton. So there's a lot of stuff in that singleton, which ends up becoming this thing where we're not necessarily sure what was in the singleton or what's not. It just becomes this almost like a garage, right? When in doubt, throw it in the garage and we'll deal with it later. All right, so that's kind of the thing. So as a programmer, we want to try to make reasonable decisions, almost thinking ahead a little bit. But sometimes that's difficult to do because a lot of times when you're learning to be a programmer, you're writing these stupid assignments that are, due in 2 days, and that's the last time you'll deal with it. Or you're only going to deal with it for this, month and a half period, and then life is over, from that perspective of that guy. So it's a little bit difficult for us to make those decisions. So I guess I encourage you to try to at least pass it through the decision-making filter as you're writing the stuff. So a singleton isn't always the right answer just because it's the easy answer. Sometimes it is the right answer. When would you say it makes sense to use a singleton in general? If you had to give just a general rule of thumb, and this isn't necessarily a catch-all, but it's at least a starting point of the conversation. Is it fair to say that if more than one other class needs access to something, a singleton should at least come into the conversation? Okay, so if you need more than one other class to access some value, at the very least you need to start that conversation. Does a singleton make sense here? Because then you got to say, well, if only 2 guys needed, and I'm creating instances of both of them at the same place, maybe it makes sense for me to just pass them directly to those so I don't muddy the waters up here. Make sense? Because at some point, we don't want our programs to, we don't want to look like slobs. Right? We want it to be somewhat organized. But as projects get larger and larger and larger, disorganization is going to happen, but these little decisions then start adding up. Okay, so at least pass that through the filter to some level. So where I was going with that idea of the singleton, we kind of get back to our, let's get back out here, not to there, get back out here. When we're deciding whether just to pass the buck or deal with it, a good rule of thumb is to make your code as self-contained as possible. It will rarely bite you in the butt. Sometimes it will inconvenience you temporarily while you're writing it. Okay, so if we were to write kind of a rule of thumb as a programmer, let's put it here. Oh, what did I just do there? That's what happens when you got a trackpad the size of a planet. Any movement slides things all over the place. So rule of thumb. Make your code as self-contained as possible. Sometimes we'll still take the lazy approach, and sometimes it's going to come down to kind of what you were saying. Look, this program doesn't do that much. I'm going to throw the 6 things up in the singleton and move on with life because I have 10 minutes to write this, and I don't really care who sees it. There's a little tiny utility. Nobody's going to mess with it again. I'm not sharing the code with anybody. It just needs to solve a stupid problem. I get it. At least you're going through the process. You're saying, I'm being lazy because it's okay to be lazy. That's okay. But if you wanted to give yourself a general rule of thumb, this is similar to when we talked about when we first introduced conditionals. And I talked about the curly braces not necessarily being required, right? Because for a for loop or an if statement, the official syntax for it, the formal syntax is if, open parenthesis, Boolean expression, close parenthesis, statement. Now that statement can come in a couple of different flavors. It can come in one line of code, what we usually refer to as one line of code, or what we commonly see is a block statement. Opening curly brace, closing curly brace with one or more lines of code inside of it. So our rule of thumb was it's never wrong to put the curly braces there. And so I said, why not always put the curly braces? Because you always gain the benefit of adding some structure to your code, right? The indentation structure, whether you like, my approach with the curly braces in the beginning or end, or her wrong approach. Either one is reasonable. But either one is probably preferable to having a single statement underneath an if statement or a for loop, right? Especially if you don't indent. I mean, Java is completely cool with you doing something like this. Let's just do it back out here in the code. Eclipse won't like it, so I'll have to force Eclipse to backspace it. But, I can say if LST is, well, it's going to be, let's do, if LST dot get at index 0, I'll just throw the equal sign in here because I'm going to quiz you on that here in a second, is equal to C, woot or something like that, that's legal. So is this. So is that. Java doesn't care about indentation. Java's cool with you putting all those in one line. Now, Eclipse tries to make you at least somewhat reasonable by indenting for you. In fact, a lot of programming languages, example would be Python, force indentation. Python doesn't have curly braces. Remove the curly braces. Well, it does use curly braces, but for something else. It's a collection type. But as far as our structure, what we usually look at curly braces is representing in Java. Python doesn't use them. It instead forces indentation. Anything that's indented under this if statement belongs to the if statement. That's the Python approach. There's nothing wrong with that. And in fact, I like it from the perspective of it encourages formatting your code to make it readable. But from Java's perspective, that is the same as that, 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 is the same as that. They're all the same. Actually, technically, you could probably say this is slightly less efficient because technically you made the compiler have to process one additional type of statement. It had to process the block statement and then find the list of statements within the block statement, which in this case was just one statement. But again, not our problem because we're the playground bully and we don't care about the feelings of computers, right? And we're kind of mean like that as programmers. So my argument is this is never wrong. And even this is more right. You probably at least put a space there, right? All right. This is more right than just having the guy sitting there, even though Java doesn't care. That makes sense? So that's kind of a rule of thumb that we've lived by, and it leads you to have maybe less errors, especially when you rely on your IDEs to do some of this indentation work and stuff like that for you. Now, with that being said, a good rule of thumb, again, that you might say as a programmer is make your code as self-contained as possible. There's actually a computer science software development word associated with that. I don't know if you're pretty early on in 370. You probably haven't talked about it yet. When I say make your code as self-contained as possible, anybody know what word we're trying to avoid? We're trying to make our code as loosely what as possible? Good. Coupled. Yep. So we can say make your code as loosely coupled as possible, which is just a somewhat fancy way of saying don't make too many parts of your code reliant on other parts of your code. Write modular stuff. Write stuff that you can reuse. Okay? I mean, that's something that might happen. I mean, for instance, I've written a whole bunch of mobile applications, and I repurpose authentication systems like they're nothing, right? You write them once with just a couple of fill in the blanks for here's your API key and crap like that. And you just move it from project to project to project like it's nothing. Okay? Write once, use often, right? Now, if I had made those authentication systems two coupled, if I had them store a whole bunch of crap up in a singleton somewhere, now I either need to move that singleton with me and then clear out the stuff that isn't related to the new project, or I need to, write a new singleton in the new thing or whatever, so it's a little bit more difficult to detach that authentication process, even though in the moment it maybe felt like it was convenient for me. Does that make sense? Now, having said that, like I said, I've been programming since I was 9, and I make those dumb decisions all the time today because it's convenient in the moment. Like, well, I probably won't need to use this for anything else. Let's throw that in the singleton because I don't want to pass this to the other thing. That's beneath me. Right? So laziness almost always ends up trumping, but from a theory perspective, at least we should appreciate this idea that make your code as self-contained as possible, reduce coupling so that other parts of your program aren't absolutely reliant on different pieces. And this becomes more and more critical when you start working with groups of programmers. Right? If you're doing everything yourself, eventually you're going to be mad at yourself because you made some decision that's making your life more difficult right now. That's going to happen, but at least it's only affecting you. When you start working in teams, which is the thing you were talking about in the 370 class, you're segueing into working in groups, and it's difficult. But a lot of times, 50% of your planning has to do with what are the outputs of my module and how do they have to line up with the inputs to this other person's module. And it might not be the way you would write stuff if you were writing it yourself. But because you're separating labor and two different people are writing these modules, they have to connect to each other, right? Think of it like the International Space Station. If China is creating a module and Germany is creating a module, and those guys are meant to plug together, they better have the holes in the right spot and the right kind of latches and things like that. Otherwise, space leaks and it's bad. I just know it's bad because you want to take the suit off when you're inside. Yeah, it's bad. Yeah, I don't know a lot about space, but space leaks are bad. All right. So make some sense? Now, I'm not going to be combing through your code looking for this decision-making stuff. Okay, I'm too lazy for that. That's what it comes down to. Now, having said that, at the very least, when you make decisions in your code, try to pass them over these filters. If you're going to be lazy, at least let it be an informed decision. And that's okay. Eventually you'll get burned enough times where you'll kind of learn like, okay, well, this is just really not in my best interest, even though it seems like it. But that's only going to really happen through experience. So at least make an effort to pass stuff over these filters and think about it for even a half second. Make some sense? Okay. So I said I was going to quiz you on something. Actually, let's go with that guy. What's the output of this program going to be? And why? So here we'll start off with this. We ran it once already. I'll give you the cheat sheet. So and here we can get rid of the memory address thing. We already reviewed that. So we have our A list. We add a couple of things to it, an A and a B. Then we display it, so we should see A and B, and then we're going to print out bucket 0, which is A. Okay, so there's our A and B, and there's what lives at bucket 0, the last A. Now I'll throw that guy back in there. What's the output of this going to be? Are we going to have one more line? Is it going to say woot, or is it not going to say woot? You think it's going to say it? You think it's not going to say it? All right, good. Fight Club. All right. Why do you think it's going to say it?
Well, I know that the reason that it wouldn't do it.
Okay, stop. Okay. Why do you think it's not going to say it?
Because get an index and string is a class, not primitive integer. It's going to return memory address, and the memory address is going to equal A.
Okay. So get it index is ultimately going to return a string. All right. Now, you would be right in every other instance. Java treats strings like they're primitives. So if we print out a string, it's going to print out as the string. Strings, while they are objects, they also act like primitives. So if this was anything else, if this was a person object, your rationale would be 100% accurate. Now, having said that, strings are treated like primitive types. Now, but see, this fight is still on, all right? Because she's actually right, but she's wrong, but she's right. And that is an accurate statement I just said. All right? So we go back here. So she said that it's actually going to return a memory address. The reality is she's right. It is going to return a memory address. If we were to print it out, we would see the string, because strings are treated like primitives. It resolves it. And the implementation of the toString method for strings has made that true. So this guy ultimately is going to return a memory address. And so I assume you're talking something about the double equal sign here. What is this guy? What's this operator? What does that do? Okay, so that's the equivalence operator. So it says, is this guy identical to this guy? All right. So now you think they're going to be the same.
I think they're going to be pointing to the same memory address.
Ah, see, that is the correct answer. When I run this, this is going to boil down to a memory address. You're right. This will print out, though, because the memory address this guy boils down to will equal this memory address. In this particular case, and this is a dangerous case, because this is one of these cases that all logic points to that she should be right. And most of the time she would be. But because strings are dealt with like primitives here, since we took the shortcut, since we cheated, this ends up being a true statement, even though it's checking something different than it looks like we're probably meaning to check, right? What we're really saying is this string A, does it contain the same characters as this string A? That's what we probably meant to say here, right? But that's not what we're actually saying. We're saying, does this memory address, is that memory address equivalent to this memory address? That's what we're actually saying. Okay? Now, so what's interesting here is they both recognize that. And they both came to different conclusions. Okay? And they're both right for, well, you're actually right for what's going to print out here, because you think woot will not print out. Okay? She would be right under every other circumstance except for strings in this case, because strings let us get away with a cheat, and we'll look at it in a second. So in this case, we're predicting that woot, you're saying woot will appear. You're saying woot will not appear, because you're saying this memory address will be identical to this memory address. Why do you think that?
I'm just assuming that because of where we first put A, that it's going to be, it'll have allocated the same, or that memory address really.
So the very first time we brought A into existence here was right there, right? When we added it to our list. This is a string literal. Okay, the string literal A. Now, it would make sense for Java to say, oh, well, you want the string literal A. Now, from this point forward, every single time I see the string literal A, I might as well go ahead and have that point to the exact same memory address. That way I don't store the exact same string in 50 different places, right? Unless the programmer tells me to. All right? Now the difference would be this. If I said, new string A, there. Where as a programmer, I'm saying, look, okay, this is a new string, a fresh string. I don't care if you already have this dude stored someplace else. This one is distinct from that. Make sense? If as a programmer, I specify that, which you would be forced to do with any other object. Okay, strings are the only object that gives us that I usually refer to as syntactic sugar, right? It gives that little shortcut, but that shortcut comes with some catches. Okay, this is one of those catches. So because we said, look, here's A, string literal A. It's going to create a little memory space for string literal A. So when I pull that A out of here, it's going to give me that memory space right there. When I say I want to compare it to this guy, it's going to find that same memory space. Okay. So there's our woot. As opposed to this, where we don't get the woot. That makes sense? Now, this is a pretty frustrating type of situation because this could be a very difficult bug to track down because you can stare at that all day and not necessarily make that conclusion. So the important thing for us as good programmers is, now, I'm not suggesting to use the new keyword with strings. Strings have the syntactic sugar thing built in for a reason. What I am suggesting is if you're going to use the double equal sign with strings, know what you're doing, right? The double equal sign is the primitive equivalence operator. And what are our primitive types again in Java? Okay. Okay, so we got byte, short, int, long, float, double, char. I usually do put char before float, so you're right there. Then Boolean, and then we have an imaginary one that's floating there that we don't see because Java doesn't have a specific syntax for it. It's our pointer. So memory addresses are considered primitive types. So this guy here is built for comparing primitive types. In this case, since we're dealing with two objects, we're talking about the memory addresses of those objects. When really what we want to compare here is the contents of the strings. Now the memory address doesn't matter. Whether they're the same memory address or two different memory addresses, is this string A, does this guy contain the same string of characters? And this is case sensitive. There's an equals ignore case version as well. Does it contain the same string of characters as this guy? Make sense? In that case, the answer will be true, whether we write it this way or we write it this way. Because we're comparing the contents of the string, not the memory address of the string. Right? And that all comes down to Java's syntactic sugar, the perk they gave us with our string class to allow us to conveniently create strings and almost persuade us not to think too much about what's actually happening under the hood. Make some sense? Okay, so let's see here. So we wrote get at index. We wrote display. Removing and resizing. Okay, so this was part of your homework assignment, right? Remove an index. So let's add one additional thing here. Actually, let's do. This is good enough. All right, so what I'm specifying here is that this guy reverses the A list. It should not produce a brand new A list. It can be a new memory address, but this guy is not spitting out. I'm sorry, this guy's going to be void. He's not spitting out an A list. He instead is going to take the original A list and make it backwards. So he can either reverse it in the original array, or he can create a new array that's the reverse of it and then make the guys point to each other. But at the end of the day, I'm spitting all over my laptop. At the end of the day, if you were to display that original A list after this guy, you should now see a reversed A list. Okay? Shouldn't be too difficult, just more getting back up to speed practice stuff. I'll go ahead and I'll post this updated code, even though we didn't write the remove it index yet. I'll post it into Slack as a code snippet. Sound good? All right, and I will see everybody on Thursday. Don't forget, Bible study, free lunch. Go to the cafeteria, just sign the little sheet thingy.